Hello, everybody. How's your hangovers? Dconf. There we go. There we go. That's the programmer energy I like to see. You can't get you excited for the talks, but for Dconf, hell yeah. All right, so we've got day 2 of Dconf 2023 in London here. Programmer energy. Nice. All right, so a little bit of housekeeping. Thanks to yesterday's shenanigans, we have a slight change of procedure. Every morning, you now need to check in with the front desk and let the person on the front desk know that you're there. And that's just a pretty simple trick, keep track of everybody's faces as they come in so that they can spot somebody that's not familiar. So, yeah, absolutely go ahead and do that. Tomorrow's lightning talks. It's great. A bunch of people have already submitted talks. We still have 4 slots left, so get on that. I'm sure there's something else you need to talk about. So let's hear it, please. And I think that's all that's all the housekeeping I have. Mike, can you think of anything else? No, we're good. That means it's time for Walter to do his talk. Programmer energy. So this is going to be one of those things that's trivially obvious to the casual observer, right? Most casual observers. All right, well, take it away, please, Walter.
I'm Walter Bright, and this is my talk. I'm Walter Bright, and this is my talk. And how many of you understand the code you wrote? Exactly. I look at, on a sliding window, all of my code that's over 5 years old is incomprehensible to me. It always seems comprehensible at the time. I always think I'm writing self-evident code, but it never actually is, and time proves how wrong I am. So that's what this is going to be. Things I've learned about how to write code that's self-evident what it does. And the goal of your self-evident code is not to show how clever you are. What it is you want to hear somebody go, that code's so simple, anybody could have written it. And it turns out it's actually very hard to write code like that. And for a related example, E equals mc squared. So simple, but it took a genius to figure it out. And since probably none of us here are geniuses, we just have to do the best we can. We've probably all seen talks and seen articles and books about, secure code and clever code and user-friendly code and all that, but I don't remember seeing a talk about how do you write code that's self-evident. I mean, has anybody seen a talk on that? One? Yeah. And it seems like, such a basic thing that you'd want to do. Maybe people think it's so basic, why have a presentation about it, or there's nothing to learn about. Why would you want to teach somebody to write code that's self-evident? It's so simple anybody could understand it, and there doesn't seem to be any value in that. But I hope to convince you at the end of this talk that there is a lot of value in doing that. And anybody can write complicated code, but it's really hard to write simple code. So at the end of this talk, I hope the takeaway for you guys is you'll look over your code you've written with a different eye. And that different eye is, maybe Walter had something there. This code is really no good. This is a real piece of code, and I actually wrote this code. And I wrote it in 1987, and it actually does something useful. And this is how we wrote code in the 1980s. And you see we've come a long way since then. I actually won a prize for this code. Who knows what the prize is I won for this?
Obfuscated C code?
It was most of obfuscated C code, and it was the most useful obfuscation. So it's about the only thing I'm actually famous for is this piece of code. So anyhow, you can see how my coding style has evolved over the years. Okay, anybody who knows anything about airplane cockpits, I don't want to hear from you. That is a lever. It's a little hard to see on the back with the background. A lever you'll find in the cockpit of most airplanes. Those of you who've never seen a cockpit before, I want you to raise your hand and tell me what that lever does. Raise your hands like I can hear you. Yes, I can't hear what you're saying. The brake? Handbrake. Okay, who's got another idea what that lever does? Throttle?
Yeah.
Okay. Stick shift, yeah. It's got the, let's go to second, yeah. Yes, sir.
Landing gear?
Landing gear, that's it. Why do you think it's the landing gear?
It goes down.
That's a good start. Huh? There you got it. See that wheel on top? It's a wheel. That wheel is there are a lot of levers in the cockpit. If you pull the wrong lever at the wrong time, this is a life or death thing. So, and often, the pilot's going to be distracted, or he may be distracted because of an emergency going on, like he's dealing with 3 or 4 warning horns going off and the airplane's upside down or something like that. And he can put his hand on that, and he knows exactly what he's got his hand on without having to look at it, because it's got a little wheel on top of it. Now, what happens when you push the lever up? Come on, guys, it's not too hard. What happens when you push the lever up?
The gears go up.
The gears go up. What happens when you push the lever down?
They go down.
Okay, so I would call this self-evident. I even took a photo editor and removed the labels off of the thing. It actually says up and down in there, but I didn't want to give the game away with that. Off? I don't know. It's not self-evident. It's either up or down. Oh, Adam, I'm sure knows.
It's because when you're going up and down, there's hydraulic pressure in the system, and they don't want the hydraulic pressure on during flight because it could cause the gear to deploy mid-flight if something breaks. So they turn the whole system off.
Awesome. So, Boeing puts enormous effort into the cockpit to make it self-evident. And, lots of times these things came about as a result of a crash. Did they say these have life or death consequences to make it self-evident? So anyhow, I think there's a lot of lessons there that we can learn in writing our code. You don't need instructions on it. So we start our journey on what is self-evident code, and yes, this was popular to do in the 1980s from people who migrated from Pascal to C, and they wanted their C code to look like Pascal. And they used the preprocessor to do this, and of course, everybody laughs at this today, but that was a thing at the time. But people still try to, when they move from one language to another, they try to make it look like their old language. Okay, that's something to be avoided. One thing that even exists in D, or in the DMD official stuff, is trying to reinvent bool. Okay, it is not helpful to reinvent things. It's arguably almost as bad as the hash-defined begin and end. And if you redefine bool as no and yes, I'll invite you to my office for some re-education. But if you did it the other way, enum yes no, you're a no hire. Something's not working in your head. So the reason is because the yes will line up with false. and the no will wind up with true, and that's just a bad place to be. So don't reinvent bool or other basic features of the language. D is based a lot on my experience and that of others of horrible things people do with their language, and I've tried to block it. Regex expressions using operator overloading, so they make normal arithmetic actually be regular expression code. And I've seen this done multiple times, and the people who've done it are inevitably extremely proud of this accomplishment. And it's a nice technical accomplishment, but it's horrible. You do not want to, again, it's the same category as a hash-defined begin and end. You don't want to do it. I/O streams, another operator overloading abuse, and the way operator overloading is designed in D is to make it hard to do an I/O streams clone, because I didn't like it, and even it took about 20 years for the C++ people to realize that I/O streams was a huge mistake. Metaprogramming with macros, you've all heard me rant about macros. ADL, argument-dependent lookup. S-Finet was talked about yesterday. That means if your code doesn't compile, the compiler won't complain about it. It's one of the most bizarre features ever of C++. So that we don't have that in D. Anybody watch Saturday Night Live? They have the salesman arguing about whether shimmer is floor wax or dessert topping, and I sort of equate that with the struct in class in C++ that you can't tell if it's a value type or a reference type, or it could be both, even worse. And of course, multiple inheritance is an abomination, so we don't do that stuff in D, and I use the language to try to stop these things from happening. So, on to another little topic. The way you want to write your control flow is it goes left to right, top to bottom, just like a book. And we do that already, right? Everybody agree that we do that already? Oops. Yeah, that's a little low. I'm sorry. You may have to look at the side monitor for it. This executes from the inside out. Does everybody see that? And which function does that comma 3 go with? You ever find yourself with the tip of a pencil counting parentheses? I haven't. I always get to the end and go, oh, I think I clicked my pencil wrong, and I do it again. And however, D has UFCS to the rescue, and isn't it marvelous? A is computed, the result is passed to B, which is run, and then the result is passed to C, and then D, and we see that the argument 3 belongs to D, and it continues on like that. It has, oh, isn't this awful compared to that? How many people write in this style? Wow, that's much more than I expected. A lot of the people you're familiar with the DMD source code will realize that we break every one of these rules all the time in DMD. So that goes back to what I wrote 5 years ago is garbage. So I'm not claiming the high ground here. Here's a simpler example. You don't normally write deeply nested things, but even in the small B of A or A dot B, which looks better? I would say the left to right A dot B is clearly better than the B paren A paren. Oh, I think the bottom of my slide got cut off. Is it possible to adjust that? The framing? Okay, I've used this example before, but what does this file do? It reads a file from standard in, it splits it into lines, and puts it in an array, sorts the array, and writes the result to standard out. And it's a very nice example how to not have any control flow. It reads left to right, top to bottom. One rule is cyclomatic complexity. The more complicated the control flow is, the less comprehensible the function is. So the thing about Star Trek is there's a quote you can use for everything, especially if it involves Mr. Spock. So one of my favorite quotes from Mr. Spock is, and I never see anyone else using this, is he gets asked about if he knows a lot about computers, and he replies matter-of-factly, "I know all about them." Like, who knows all about computers? Yeah. So this kind of code, red is bad, okay? This kind of code appears depressingly often, and if you can figure out a way to rewrite it like that, it's going to be a lot better. One way to do that is to put these conditionals inside those functions instead of at the call site. You put it in the callee. And then your main loop or your main code just looks a lot nicer and is easier to read than this jaggedy mess, what you normally see in code. Now we get to negation. Nobody helps nobody but himself, and of course Spock comes in and correctly identifies you are employing a double negative. The problem is in English, we use double negatives all the time, and we don't use it to negate, we use it to emphasize. So you'll even see sentences that have triple negatives, and they don't flip-flop the state with each negative. It serves as emphasis. So when people start looking at code with double negatives in it, they get confused. It's a cognitive problem. Andre argued with me that I have no evidence to back this up. I just felt it to be true. And about a year later, I discovered a paper where somebody actually did some research and found out that, yes, people fail to see negatives in code or negations in code all the time and misunderstand it. So, of course, I triumphantly waved this at Andre, and Andre, being a decent fellow, conceded defeat. So it's really tough to catch Andre. Okay, so to restate this, if not no way is perceived as no way. So how many of you have made that mistake reading your code? Yeah, lots of you. So what's the trick? The trick is do not use negations. You reframe your variable names and their sense as being a positive. So if not no way becomes if way. This kind of shows up when endless discussions about how to do versions correctly. This argument went on or debate, I should say, went on in the news group just before I came here. And versions do not allow negations. You have to think of it as a positive. Well, you don't have to. It just makes it difficult to write it as a negation, because I'll make you use the else thing rather than putting a not in there. And if you look through the source code, most of it has been gotten fixed over time to not use negations here. And we use version Windows, version OS X, or the default is unsupported. So when you bring up a new operating system, the compiler is going to tell you every spot where you need to adjust the code. So this has worked out fairly successfully, except for a couple people in the news group who argue with me about it. Okay, welcome to the DMD Source Code Hall of Shame.
Back to the last slide.
Okay.
Isn't the stat static asset a no-op?
What?
That static assert is a no-op, I believe, because it does not have that zero that makes it fail.
You're missing a
Oh.
zero.
You're right. Missing the 0 comma there in front of the string. You see, I can look at that 10 times and not see that it's missing the 0. Thank you for pointing it out. Okay, the DMD Hall of Shame. This is actual with even a brief look at the DMD source code. You'll see is no throw, no return, no access check, ignore symbol visibility, not computed, and unbelievably, there's a message in there that prints to the user, not no throw. I was sorely tempted to submit a PR, not no way after that. And it's all backwards. It should be, it throws. It's not no throw. I mean, how is that absurdity even possible? It also turns out that if you have a bunch of conditionals, A and B and C and D is really easy to understand. A or B or C or D is really easy to understand. What isn't easy to understand is logic like, the red example down there. I often find myself staring at those, trying to convince me that it's correct, or trying to convince myself that the logic is actually correct. And I spend an inordinate amount of time doing that. And I finally realized what I need to be doing is rewriting them as the above scheme. Of course, De Morgan's theorem to the rescue. Anybody not know De Morgan's theorem? Wow. Okay, De Morgan's theorem is these two transformations are always true. And you'll notice they get rid of one not. So they make code better by reframing the code with fewer negations in it. Now, ideally you want 0 negations, but at least with De Morgan's theorem, once you convince yourself that De Morgan's theorem actually works, you can apply it kind of blindly and just reduce the number of negations, which of course gets compliment from Mr. Spock. This I was looking for something nasty in the system header files, and it didn't take me more than a minute or so. Can anyone even find the negation in that? You're not going to see it. It's right there if you can find it. And Professor Marvel is my other favorite source of quotes. Casts hide bugs. That's why, in order to do a cast, there's a keyword for it in D. It's not special parentheses syntax. So the idea being you can use grep to find your casts, and then you go through your code and try to eliminate them. And there's a pull request that I did, and there's the URL for it. I've gone through much of the DMD code just to get rid of casts. And yes, sir.
Sometimes I found that they're almost unavoidable. Like when dealing with network port numbers, which are short, there's no way to enter in a short constant. So if I do any kind of arithmetic, I kind of find I'm trapped in a corner I have to cast.
You're right. You can't get rid of all of them. But you can get rid of an amazing number of them by appropriate use of aliases and just thinking about it carefully. And I know this because I've put a lot of pull requests into the DMD source code, which is just getting rid of casts. Every cast is another potential bug removed. There's another way that D will help change the way you think about your programming, is a C-style declaration above. And what are the problems with it? Does P modify what it points to? Is P returned? Does maybe XYZZY freeze P? Does XYZZY save a copy of it? Does XYZZY throw P in an exception? You can't tell from the declaration there, which means you got to document it. And you know what they say about documentation. Documentation is always wrong, misleading, or absent. So you don't really, what I'm trying to do here is show how you can use D features to reduce the amount of documentation you have to write. And everybody hates the annotations, but the annotations tell you things about the parameters that you don't have to document, and the magic is the compiler enforces it. And you can rely on the compiler enforcing it unless it's one of those cases that Timon likes to torture me with, where he found a way to yeah, Timon has an amazing ability to find every hole in the dike. But that's where the attributions come in, is they eliminate a lot of the wrong documentation that you don't have to write. Memory allocation, a constant problem. So one way to deal with it is have a function when it needs to allocate memory to make it self-contained. If it allocates the memory, it frees it, so the color on the documentation never has to be concerned about it. But if it's going to return something that it allocates, one technique is to design an allocator and pass it in as a parameter to the function. And this follows the idea that everything a function touches should come in through the front door and should go out through the front door. And by the front door, I mean the function declaration. So how do you deal with output? Instead of having the function do the output, have the function provide what's called a sink, where you pass the output to the sink and let the caller worry about where you actually send it. So here's an example of a, I shrunk it so it fit on the slide. A PR I recently did to redo how errors are written in DMD, because the default error handler is a global function that you call, and it writes it to standard out after decorating it with colors and other things, and there are other global variables that switch around its behavior. And I thought for a long time that that's an awful system. It introduces lots of dependencies. It makes it very hard to write DMD as a library. So Jacob Karlberg did a stab at this, and I did another stab at this where I finally managed to reduce it to an abstract interface, which I don't show here, which I think most anyone can understand what it does by about 30 seconds of looking at it and requires no documentation. So anyhow, now we do errors in DMD by passing a error sync, which is an abstract interface. And that means it greatly reduces the number of imports these functions have. And by passing different kinds of error syncs, you can get different kinds of behavior. Like if you're doing a speculative compile, you can pass an error sync that just simply does nothing, doesn't log the error message. And there's the pull request down there if you want to see what the actual pull request looks like to do that. You'll be able to download the PDF, so I really need a picture of it. Okay, another thing that the DMD code would do is it would call these modules that would do something like generate a documentation file, and then it would write the file out. So what I did here was writing a file is not going through the front door. So instead of, oh, this is reading a file, yeah. The old version would pass an array of file names to it. And the first thing the function did was it would read those files and write all the data to this giant buffer. The next version of it that I recently did just gets the contents of the files as a single array. So now the documentation generator doesn't have to worry about doing any file I/O. It just has to generate a buffer with all the resulting text and let the caller worry about it. And this has a marvelous feature of making this function unit testable, where it was nearly impossible to unit test before. By controlling the inputs to the file through the front door, as opposed to getting things from the file system, it becomes much more testable and much more understandable. The documentation file would also pull some of its parameters. Yes, sir.
Just a brief question on the previous slide about reading files. If the files are very large and may not all fit in memory, does this kind of change the memory footprint profile of your program? Because now everything has to be loaded up front?
There are gigabytes of memory available. I just don't see that your project's going to generate that much. I don't think it's it hasn't been a problem. It won't even notice it. Certainly, there are cases where passing a buffer in can be extremely large. What you can replace it then with is an interface that gets it in chunks. So you're still not reading the files. You're calling an interface supplied by the caller that reads the files for you. And that would, by chunking it up, then you could avoid the problem of consuming too much memory for that. You don't want to modify the behavior of your function using the environment. The environment should be collected, all your parameters should be collected by the caller and then pass through to this. Another way to say it is your engine, your core engine should not be interfacing to the operating system. If your core engine, unless it's a GUI engine where you're kind of stuck with that, should be independent of the operating system. You should not be importing Windows, the Windows modules or the system headers in your engine. It should all be done up front, passed in through the front door. Your engine does its work and sends the result back out through the front door. That makes your code much, much more portable and much more understandable, because all the imports to operating system files disappear from your engine interface or your engine module. And the same thing goes for writing files. The original would call a function that would write the file. The replacement took a parameter, again from the command or from the function header, that told it where to send the output to. And how cool this is for unit testing is you have a buffer with the input and a buffer with the output, and your unit test just has to compare the output with the known what it should be, and it doesn't have to do any file I/O at all. So it makes unit tests very self-contained and simple. And of course, there's the pull request with the actual change to the code, so you can compare it with the slide. I had another problem. It took me a minute to figure out how to do this. The documentation generator macro processor It had to deal with Unicode. And the only thing it needed the Unicode for was determine, is a code point or code unit the start of a start of an identifier or a one that belongs as part of an identifier. And the Unicode handling code is another large, complex module, and all I wanted was those two little functions. So then it occurred to me, of course, I just pass what those functions actually do as a pointer to a function, then the macro expander doesn't care about the mechanics of them. It just, well, there's a pointer to a function, it does it for me. Another way to do that is make it the processing function that's coming from somewhere else, you make it a template parameter. But since the macro processor is not a speed-sensitive thing, using a function pointer is better than using a template. So if you look at the macros, it's called dmacro.d, there's the pull request for it. You'll see that the number of imports declarations to the macro processor shrank dramatically with this. Functions. There are two main categories of functions. One of them asks a question about the code, and the other one does something. And I've always combined the two. For decades, I'd have a function that not only asks a question and returns some state, it also, fiddles around with the data in there, and it took me a long time to realize that that should be split up into two separate functions. And the neat thing is, the one that asks the questions you can even make it pure, of course. And I realized that my design was bad when there was no way I could make this code pure because it would alter the state as it was answering questions about it. And by splitting the two into separate functions, I could make one pure. And then it's clear that from the reader of the code that I can get answers to the state of the data without modifying anything. So it also helps to decide on some prefixes for your functions to make them self-documenting, like is determines what category something is, and has asks if it has a certain characteristic, and do means it's actually doing something. This is why I don't use automatic formatters. They never line things up. The neat thing about lining things up is your brain is a very, very good pattern matcher, and you don't have to closely look at the code to see if something's wrong with it. Because when something's wrong with it, the pattern matcher in your head is going to go, that doesn't look right, and you look at it and you realize that the code is wrong. So by lining things up and as much as possible with space, you can make your code much easier to read and understand, and it's much easier to just visually check that, yeah, it's right. Of course, Dr. Marvel is, his decisions are always cataclysmic. This goes back to what Robert said yesterday, use ref instead of star. And since a lot of the code base from DMD originally came from C, there's a lot of use of star that can be replaced by ref. Okay, takeaways. One is use the language features as intended. Don't try to be too clever with them. Go through your code and see if you can avoid as much negation as possible. Try to reframe things in terms of positives. Try to get the flow of control instead of spaghetti flow. You want it to go left to right, top to bottom. Functions do everything through the front door. They don't try to come in through the side. They don't store things in the globals. They don't call the operating system internally, and they don't write any files or read any files. Don't confuse the engine with the environment, yeah. Reduce your cyclomatic complexity by trying to hide conditional branching in the functions that do the work instead of the caller to the function. And there is no end goal in this. It's kind of a continuous improvement kind of thing. You'll constantly find ways to make your code nicer. And I encourage you to keep trying. So, questions?
Well, applause first. As with yesterday, I am monitoring Discord and YouTube for some online questions. But yeah, let's get one of these audience questions. I saw a hand over there.
Yeah, a question about how do you actually use the language to help you document the usage of ranges. I often find myself in a situation where I'll take a template argument that's a range, and then I need to return in the range, and I'm left using auto, and I can't put in the language a way of describing what kind of range is and what property it has, and I'm left using documentation. Do you have any suggestions on how I can use the language to make those constraints more concrete?
The only thing I can think of is naming convention. Have a naming convention that gives you a clue what kind of range it is. Sorry, that's the best I can come up with on short notice. But yeah, I think using a naming convention will help out quite a bit with that. Come on, you got to be arguing with me about it.
Yeah, so you talked about the moving the negation, the exclamation point out. And one thing that bugs me all the time is expressions.
Is expressions?
Yeah, if I want to find out if something is not a type, there's no not equals inside these.
No, there's not is. Put the bang in front of is.
No, is expressions, not the is operator.
Oh, yeah.
You have to put not is type equals. It just reads really weird.
Sorry. that was a very early feature in ND, and you know, it was years later everyone started talking about pattern matching, and it suddenly occurred to several of the D users that inadvertently D had pattern matching in it in the form of the is expression. But that's another story. By the way, that is me. I decided in my old age to pick up a new hobby. And about 1 mile after that photo was taken, I crashed the bike and it fell on top of me, and I sprained my ankle and I couldn't walk for a couple weeks. So I encourage everyone to take up dirt bike riding.
Walter,
Yeah.
this is not a question, but I committed one of the things you said not to do.
Uh-oh.
Function.
Out.
So I wrote a function that would do multiple things with multiple files. And later on, I realized I needed one statistic value from this function, and it returned one single long value from that function. So I'm committing the crime of doing things and also returning a result that is useful to the caller.
Yeah.
Just saying, I did it, and I can't imagine an easier, cleaner way of doing it, redoing it. Maybe I'll find one tomorrow.
Well, that's really what all the fun is in this, is not accepting that your code is as good as it can get and constantly look at it. You know, just open a file at random and look at it. And you're almost guaranteed to find something that you can make better. Almost guaranteed, because almost every time I can see it, even if I've been over that file many, many times, you know, 6 months later I'll look at it and go, oh, well, I can simplify this a bit here and this a bit there.
Walter, thanks for the presentation. One comment is that when you're trying to help people improve things, it's very often useful to state things in the positive. as in do this, and do this, as opposed to don't do this, don't do this, don't do the other. This is particularly visible when you're trying to say like coach an athletic capability, right? You don't tell someone, don't look at the bat, don't do this, don't do the other, because invariably the subconscious will flip it, and they'll do exactly that. So it's easier. I think it relates to the sets that are involved, right? When you have a positive thing, you have a singular thing, and you look at it. And when you say a negation, effectively you're telling the brain, you've got to paw through the set of all possibilities and weed stuff out. So it's just a suggestion that when we try and help people improve their code, we tell them more often what to do as opposed to what not to do.
You're absolutely right. I find that when I discuss things with people, the first word out of my mouth is no. How many people do that? Yeah, it's an extremely bad habit. And I write my emails and posts, and they always start with the word no or but. And after I write it, before I hit send, I look at it and I find a way to rewrite it as a positive and not start out with no or but. But that is, a deeply ingrained bad habit of mine. And you're right, it applies to just everyday talking about things.
The reason I think we go negative with the negative is because it's precise and it's direct and it's localized, right?
And it's rude.
Well, it's also rude, but it's also harder for us to flow with and just mentally. So yeah.
Yeah. So it's not just code I'm trying to, reframe my methods. It's, in daily life I try to stop using negatives. Say the same thing in a positive way. It's almost always possible to do that.
We have an online question from Ricky.
Also, I would like to say that given this thing you just said about using buffers instead of files, this is a thing I have been using a lot in my porting projects, especially because you have a lot of different things for a process, something like decoding or everything. So I think this is a pretty good practice to stick when you're doing some kind of portable code. And in that same thing, I also would like to say, given that you still have this portable thing, you also need to have the convenience way to do something. So whenever I'm designing some kind of function that should be reading a file, I write one which reads from buffer and one which just called this function reading this file. I think this actually helps a lot. And this same principle applies to what you just said of a function not calling if is and with other things. I guess you can just create a composite function which does all of that.
Now, there's a hidden advantage to using buffers instead of having it write the file, which I discovered, is the caller may be making multiple calls to functions that, return buffers, and it turns out you can recycle the buffers. So you save a whole bunch of thrashing of your memory allocator if you use the input and output buffer approach. So it's not just a stylistic thing, it's a performance improvement too.
Right, now we have an online question from Ricky. Have you considered creating a new scope in a function to divide steps? He finds that it has all the benefits of nested functions without any of the downsides.
So nested scopes?
Yeah, basically. So
Yeah,
splitting
sure.
your function up into multiple scopes.
Yeah, that's a valid, and I do that. I like to keep the scope of variables as small as possible, and by using multiple scopes, you sort of logically, because you see the end of the scope thing, and you know that your variable p isn't going to be used out beyond it. So yeah, that's a valuable technique.
You've touched on this in your talk about global variables, and from my experience, it seems that global variables are almost always a bad idea, or at least writing to globals. So I was wondering if have you ever thought of a solution of maybe restricting access to global variables in a way, or?
Well, you know, you're absolutely right. Global variables are almost always a bad idea. Where they're a good idea is if you want to fix a bug without making a global change to your program. Okay, if you can fix it with a global variable, that way your PR is small and easily reviewed, and then later you can refactor it and move the global out into a stack variable on a caller or something like that. And I've done that before. I'll use a global to get the PR, get the bug fixed and whatever. Then I'll refactor the global variable out of the code. And that has a nice thing of separating one complicated PR into two distinct ones. It makes it much easier to review. If you make a mistake, it's easier to find the source of the mistake. So, yeah, and I've done a lot of refactoring of DMD to get rid of global variables, but there's a long way to go with that.
All right, that's about all the time we have for questions. So thank you again, Walter.
My pleasure.
All right, back up here at 10 o'clock for the next talk, everybody. Have fun.